Hello, today I'd like to talk a little bit more about expected value, but in a bigger way, because expected value actually reminds me of my grandfather, because he was a huge bettor on the horse races. He actually had this fantasy that he would somehow support his family through gambling. And, well, it didn't work out, not surprising. But he tried for a while, and he went to the races, and he would go every day. Um, until he lost all his money. But actually, once he did, he then got a job in a deli and pulled it together. But he never actually totally stopped going to the races. He'd still go once a week and he'd take me, and it was really fun. And he'd still lose money, but he kind of kept it under tabs. Anyway, I want to tell you what you need to think about when you're betting for horse races and looking at expected value. So expected value, as you remember, is this beautiful equation right here. And so we're going to use that to really look at and decide, is it smart for my grandfather to bet on horses? All right. So he likes to bet about $1,000 a night. That's what he brings in and lets himself do. And his favorite kind of horse races is with buggies. And I actually have to say he doesn't bet anymore. He passed away. But anyway, so he likes to bet on the buggies. And to figure this out, let's first look at this expected model of betting. So we're going to build a probability model. Now, probability model sounds fancy, but you actually know exactly what it is. It's basically just a table showing you all your possible outcomes. So we have our payout, that's our X. So if you get first place, $5,000, second place, $4,000, third place, $1,500, and then if number 5, which he loves number 5s, doesn't win, then you just don't place. Now, to figure out the expected value, of course, you need to have the probability. And actually, in betting, you can figure this out. You get the horse race booklets, and there's the history of the horses, so you actually can kind of get an idea of the probability they'll win. And so here's some probabilities. And then we just have to check to make sure it's correct. So, of course, all the probabilities always add up to 1. All right, so let's find the expected value. So we have our equation right here, and this tells us that if we take the x and we multiply it by p, we're going to get part of the equation, part of the answer right here. We call that the weighted values, and so we go ahead and multiply them, and then this little summation says once you've multiplied them, which we've done right here, you add them all up. So he can expect to win $1,025. Now, of course, he bet $1,000. This is about a win of about $25. All right, so he's excited. He's like, oh yeah, great, I come up ahead. $25, still ahead. But the truth is, no one actually wins that. The weird thing about expected value is it's terribly worded. It should probably say average value. This means if he plays over and over again, $1,000 every night for a year, on average, this is how what he's going to do. But we know that what really happens is you get big payouts or nothing. So we have to kind of think about this for a little while. Is expected value enough? This is a risky deal with all this betting. So we might want to think about if it's okay. And to really analyze it further, we need to look at that wonderful thing called standard deviation. So we're going to do that today. You might want to have your notes out. All right, standard deviation, you might remember, we used to look at it before in the last unit, and this was that beautiful equation that showed us how spread out the data. So if an average was something simple like 10 and your standard deviation was 5, it meant that most of your data points are between plus or minus the standard deviation. That would be between, if your average was 10, most of your data would be between 5 and 15. Great. All right, but expected value is a little different, so the equation is going to change a little bit. This is what it looks like this time. And so I want to go with you how we can find it in a situation with betting on number 5. So here's your equation. E of x, that's expected value, which is equals. X is each possible outcome. All right, so that's that winning first place, second place, or third place, or no place at all. P of x is the probability of each of these outcomes happening. So if you go through it, here are all of the steps. I'm going to actually walk you through these for this example. Here we go. So first thing you do is you've got to subtract your outcome from your expected value right here. So here's the outcomes that we've got. Our expected value was 1,025, and so we come up with all of these numbers right here. Next step, we're going to square the answer. So basically, I'm just building up this equation. I've done this part, now I'm going to square it. So if I square it, I end up with these squaring for each of these numbers that I got. The next step right here is I multiply what I've squared by the actual probability right here. And when I do that, I end up with these values right here. Okay? And the final step is to add them all up. So I add them all up, and actually I have one more step. I have to take the square root. And I end up with 1,536.84 cents, which I'll just round off to 1,537. So you can see that my expected value is here, which is making $25, but my standard deviation is much larger than that. Okay, so this means that you're likely, or my poor grandfather's likely to make either $1,562 or actually lose $1,000. This would be losing beyond just what he actually paid. So these are our max loss. So now you need to kind of think a little bit harder. That means that it's pretty spread out, the standard deviation, and so great things can happen, but really bad things can happen. So you might think twice before you start gambling on number 5. All right? So the big point I really want to make is first make sure you know how to find the standard deviation of expected value. But it's because expected value is not enough when you're looking at decision making. And you use expected value to make very big decisions, not just about racehorses, but about investments, building up your company. So you always need to ask yourself, what is the standard deviation, if it's small or large? Okay, when it's small, that means that what you can expect to happen is probably close to that exact expected value, right? It's not very spread out. But if it's large, that means that the earnings are super spread out, so they can swing from very high to very low. So you need to be sure that you can handle those losses, since they actually happen a lot. All right, I hope this all makes sense to you, and I hope you'll enjoy the classwork.